Okay, so again, starting super easy. Trinomial A value is 1. It says factor, which is what we need to do, not solve. So factor. If you wanted to solve it, like see where it crosses the x-axis, I humbly would say drop it into Desmos at this point in our math career and just save yourself some energy. But factoring, this is the star you normally see. I'm going to work it the way I like to work it because this works for the bottom two as well. And like I said, most of you don't have a problem doing these. It's these where you get a little like frustrated because the numbers get wild. And I picked some where the numbers weren't terrible so we could get through them fast enough. But the process is still the same. So A and C goes on the top, B goes on the bottom, AX, and when I say AX, it's whatever variable they use. The variable does not matter, except if you have to type in X equals for part of the answer to your question. So then in that case, it does. So you need to know your A value, your B value, and your C value. A is the first one, B is the second one, and C is the third one. So from there, we now are going to do A times C. So in this case, that's 1 times 8, and that goes on the top. And our B value goes on the bottom, which is 6. And they are both positive. When your B value is positive or negative, that's a telltale to decide on your positive negative factors. The larger factor will always match the positive or negative of the B value. And then in your upper right hand and left hand corners, you're just going to take your A value, which in this case is 1, and put 1x. And again, we're using x because this is an x. At Pinecrest, when I went around and asked every teacher how they factored to see if there was any commonalities, the one thing they did there was an ACB chart. So AC is 8, and that is like the only thing that every teacher did the same. So as I've said, when we first did factoring, if you have a different way of factoring and it works for you, rock and roll. Do it. Because I'm not trying to unteach anything. So we're thinking of the numbers that multiply to get 8, 1 and 8, 2 and 4, and then in my mind I go 1, 2, 3, and then I hit 4 again, so I'm done. Some teachers do make you rewrite this all the way through, like 1, 8, and then go all the way down probably really until you get 8, 1. I'm not a fan because most of you, if I can get you to write this much, I feel good about it. 8 and 1 would add to give you 9, subtract to give you 7, and we're shooting for a 6, so this is not it. 2 and 4 will give me 6, so these are going to be our factors. The largest factor is going to be that 4, and because the 6 or the B value is positive, I know the 4 is positive, and I'm probably over talking for some of you guys, but again, this is just the thought process that I go through when they are harder. And then in this case, we need this to be a positive 8, so positive 4 times a positive 2 gives me a positive 8. Positive 4 plus 2 does give me 6. Now, and I say this to the point of probably obnoxiousness to you guys because I've had math teachers scold me for teaching it this way, but it works and we can get it right. So that's why. This is not a fraction, but we are going to pretend like it is a fraction and check to see if you can reduce. If A is 1, you will never be able to reduce. But you're doing that so when A is not 1 and there's not a GCF, you have the steps in your mind already. Since it can't reduce, this is a positive 4, that's a positive x, so it's going to fall over, because in my mind, that's what it does. Like this falls down here, and this falls over. So it falls out of its not fraction form. Again, not a fraction, 1, so we can't reduce, so that's going to be x plus 2. A lot of teaching for that one, because most of you probably could have done that without any of that conversation, but just again, that process works better for the not A is not 1. And then, like I said, if you're not strong, I highly recommend picking up this process because it will work every time. As long as you are in charge of pulling out your GCF appropriately for in this case. Differences in squares. So the video that was yesterday, they did this the same way this one was done. I would not do that. I would remember that if it's both of them are square rootable, like I can take the root and they're perfect squares, just know there's going to be 2 sets of parentheses. One's going to be positive and one's going to be negative because every time you take the square root of any number, you have a positive and a negative. Our variable is x. There's going to be an x in both. And in this case, the square root of x squared is asking, what do I multiply by itself twice to get x squared? And that's x times x. And then the square root of 25 is positive 5 and negative 5. For some reason, this one messes people up thrown in the rational unit too. And I think it's just because there's so many different ways to factor that you forget it's that easy. So if it's a binomial, there's a subtraction in the middle, only subtraction, so it's difference of squares. You can ultimately just open up to positive, negative, square root the front, square root the back, and those are your factors. Now, this does not necessarily deal with this lesson, but just as a reminder, because our EOC is super close, these are factors if it asks for solutions. And solutions would be x-intercepts, roots, zeros, and all of those fun things. You're going to take each one of those, set them equal to 0, and solve. So you're solving for x to find the solutions, x-intercepts, roots, and zeros. And I will beg of you to write it out, because a lot of you have gotten to where you just know that it's going to be x is negative 5 and x is positive 5. Beautiful and awesome, like 7.5 out of 10 times. But sometimes you have a 2x plus 5, and a lot of you jump too fast and just say negative 5 and don't do the division of the 2 in the front. So especially on EOC day, highly recommend taking it just 2 seconds to actually write that out. If it asks for solutions, roots, zeros, and so on, x-intercepts. That would be what that is. So 2 of the very, very basic factoring. All right. So a little harder, but not terribly hard. So our A value, our B value, and our C value. So A is 2, B is 11, and they are all positive, and then C is 5. And so when we do our big start, A times C goes on the top, which is 2 times 5, right? So at the top, we're going to get a 10. And then B goes on the bottom, which is 11. A times X, and if I'm writing too fast, give me, or like if you're trying to write with me or trying to work it with me, give me a holler or make some racket and I'll slow down. So A times X, A is 2. So we're going to put 2 times X, 2 times X. And I messed up to what I preached to you guys. If A is not 1, check for a GCF first. Always check for GCF first. It's because I already looked at all these to make sure there wasn't one. GCF first. And ideally, I would always try this first number, because if you can get this down to A is 1, it's way easier for most of you to be able to factor in your head. Like, you don't have a problem with those. But in this case, 11 is not divisible by 2, and nor is 5. And both of those are prime, which is another dead giveaway. There's not going to be a GCF. So our ACB chart, or a lot of you, again, do this in your head as well. You're looking for the factors, like multiples that give you 10. So 1 and 10, 2 and 5, 3 is no good, 4 is no good, and I'm back to 5, so I'm done. 1 and 10 will give me 11, so I think this is a good one, but I'm going to check, because there is, my favorite one is when the C value is 6 and the B value is 5. 2 and 3 can give me 5, and 1 and 6 can give me 5. So just make sure you're paying attention that sometimes there are good answers, and then sometimes there are right answers, if that makes sense. Like super close, but not quite. It's really just that 6 and 5 combo. But again, habit, make sure you don't stumble into that and miss it. Habit gets you to where you get them all right. So 5 and 2 is going to be 7 or 3, so that's a no-go. So it's 10 and 1. So 10 and 1. I'm going to go look at my B value. B value is positive, so I know the 10 has to be positive. And then 10 plus 1 is going to give me that positive 11, so it's also going to be positive. Now, not fraction, but we're going to look at this stack as if it was a fraction, and 10 and 2 are reducible because they're both divisible by 2. Do not get rid of this space holder, so it's 1x, and then that's going to become 5, so again, not fraction. 1x over 5, because 1 over 5 is the same as 2 over 10. Check my 2 over 1. Again, the cool part, when you see a 1, you know it's not going to reduce. These guys fall out. So 1x plus 5, because it's positive. These guys fall out, and that's 2x plus 1. So whatever's on the top goes in the front. Whatever's on the bottom goes in the back. Bottom, back, bottom, back. So B's here. If the fall down part that I call doesn't make sense to you. I'm a visual person. It looks like they fall to me. And then you've now factored. Also, if you're not super strong on factoring, as I mentioned, go to Desmos, put this in the first equation entrance, and then put this in the second. And if they do not graph directly on top of each other, you made a mistake. And that's not something you have to do necessarily every time, but definitely on EOC time when every question helps and counts, because you need 15 right to pass, 15-ish right to pass the test because of our curve. These kind of questions should really ultimately be easy, because there's no reason you can't get them. Like, you're not running down the wrong rabbit hole and not being able to tell that you did it wrong. Like, you should be able to know that you did it wrong. It may not give you the right answer, but it'll let you know to go back. All right, so we're going to do A, and I guess I should reach out. Any questions so far? Is everybody okay so far? Awesome, awesome. All right, so A is 2, B is -7, and C is -15. Now, I've had lots of students laugh at me, especially some of you guys are going to laugh about doing this. On EOC day, you're going to have 107 things going on in your head. Nerves, 60 questions, sitting in a room instead of sitting at home. Taking the second to do this will help you not forget these negatives. So again, it's one of those things that's not 100% necessary, but it just keeps our mind straight so we don't make silly hiccups or get distracted about things. So that's why I always do that. Plus, if you guys have been with me long enough, you understand that I get distracted quite easily and make silly mistakes. So this is also my self-check. So A times C is going to be a -30. And then our B value is going to be a -7. And our A value is 2. So we're going to do 2x, 2x. And I did it again. Check for a GCF. 7 is prime, so there's not going to be a GCF. And nothing in here is divisible by 2 except the one in the front, so that won't work. 15, my first ones I think of would be 3 and 5 because they're smaller numbers, and those won't work either. So ACB chart, -30, -7. So what multiplies to give me 30, adds or subtract to give me 7. So 1 and 30, 2 and 15, 3 and 10, 4 is no good, 5 and 6, 7, 8, 9, and we're back to 10 again, so we're good. Also, if you have access to a TI-83, which you will on EOC day, and that is up to you whether you want to use it or not. I've shown you this before, but just in case, maybe we'll remember it if I show it to you again. If you go to y equals, and 30 is not a terrible number, but if we do 30 divided by x, and if you remember this but don't remember the button pushes on that day, just run up to me and I'll show you. Hit second graph, all of your factors. So 1 and 30, 2 and 15, 3 and 10, 5 and 6, 6 and 5, and you're done. So now that when I say you're done, like they repeat just opposite. All right, 1 and 30 are not going to give me 7. That's 31 and 29. 2 and 15 give me 17 or 13. 3 and 10 look pretty good because 10 minus 3 would give me 7. 5 and 6 are 11 or 1, so that's no good. So this is the one we're going to use. So we're going to go drop a 10 and a 3 in our big star. Go back and look at our B value. It's negative, so then I know the 10 has to be negative. The larger of the two has to be negative. Then I need a -7. So this means I spent 10 and I got 3, which is -7. If I spent 10 and I spent 3, that would be a -13. So we want to make sure that we're making good choices here. So then we're going to look at our not fraction again. We have a 2 over 10 again. So it is going to reduce to 1, -5. That's 1x, -5. 2 and 3 does not reduce. 2/3 is as good as it gets. So we're going to fall over x minus 5 and 2x plus 3. And those are your factors. And again, if you need solutions, roots, zeros, or x-intercepts, you're going to set those equal to 0 and solve them. Or if it just says, what is the solution? What is the answer? Solve the quadratic equation. You can also always use Desmos to see where it crosses the x-axis, or you could use quadratic formula, which I don't know why people do that, but people do choose it. So if you like it, rock and roll. I personally think it's a lot. But down quickly because we're running out of time already. So I gave the first two where you didn't have to discuss factoring. So it's 2 problems, so it's 2 rationals. So yesterday you would have just done this one, and it would have been where you factored it to get it to that point, and then you would start crossing things out. And in this case, hopefully you see the 2 p's can cross out. You can cross out from this point in multiplication as well. So if I look at that, those 2 cross out, and all I'm left with is p minus 10. Maybe put a 1 right here, especially if you happen to be using a colored pen so it doesn't get lost. So you know something has to stay in the numerator. I've watched students magically make that p minus 10 the answer. And remember, if it's in the denominator, it has to stay in the denominator because that's very different. 1/2 a dollar is very different than $2. And then you would have gotten the second one and factored this guy out. And hopefully you see at this point, P plus 1 and P plus 1 can be crossed out because they match. I'm not sure how hard they hit this home on the videos enough for it to stick for you. If the P plus 1 and the P plus 1, if there are two, I guess they're actually terms at this point too, connected by addition or subtraction, you can't cross out one part of it. The whole thing has to go away. Like you can't rip off his arm and throw it out because there's another arm sitting at the top. If it's attached to a body, like R plus 1, they have to go out as a team. You can't get rid of part of it. So in this case, and then again, maybe put the 1 down here. Now multiplication is exactly the same as multiplication of any other fractions. So if it was 1/2 times 3/8, sorry, I'm having a heat stroke, 1/2 times 3/8, you would just work straight across. And it'd be 1 times 3, which is 3, and 2 times 8 is 16. We're in high school now, so we would check and see if we could reduce it. In this case, we cannot, but then you would be done. Same exact process, except that you do want to get rid of what matches. And if you do it on the front end, then you won't have to do it on the back end. So doing it on the front end here, we have 1 times 10, so that means there's going to be a 10 on the top, because that's it, across the top. Across the bottom, I have P minus 10 and a 1, so you could put the imaginary 1 if you want, but you don't need to. And this is what I'm talking about. We have a 10 at the top and a 10 at the bottom. So this is a floating around 10. This 10 is attached to that P, so they cannot cross out. It has to be a P minus 10 at the top or a 10 on the outside standing alone. And then you have now solved by multiplication. Excluded values would happen before we crossed out, just as when you simplified the singular rational. So excluded values, we would have set 2P equal to 0, P minus 10 equal to 0, and P plus 1 equal to 0. And then you're going to solve. So divide by 2. So P equals 0, because 0 divided by 2 is no good. And that is P is not equal. In solving, it's P equals 0. In the instant of excluded values, it's P cannot be 0. So excluded values are the list of numbers that cannot work in this function. And also in the division video on Friday, you'll see it too. I call these bombs because if the bottom of any fraction becomes 0, the whole thing blows up. You have to stop. You can't do anything with it. If you've plugged it in TI-83s, like 4 divided by 0, back when you weren't really confident with those, it gives you an error. And that's because the function just blew up. You can't have it. You can't do it. So add 10, so P cannot equal 10, and subtract 1, so P cannot equal a negative 1. You will see it written as a list as well of excluded values, so that negative 1, 0, and positive 10. In a graph, you will see those as wholes because those x values do not match this function, are not usable in this function. So again, number 6 is already factored for you, so you don't have to go through that part as far as just multiplications. We're just discussing the addition of multiplication to the process. This guy looks good. There's nothing top to bottom that I can cross out within that 1. And then same over here, nothing crosses out here. So this one I'm not going to cross out from this point. I'm going to use our multiplication rule or rewrite it. So 8 times 5 n plus 1. And so in classrooms, I usually tell people, like, you can ultimately just do this, cross right through that multiplication symbol, and you're cleaning up the top and you're cleaning up the bottom. And that's it. I think multiplication and division, actually, wildly enough, said no one ever, is insanely easy, especially if you can factor. Factoring is usually where most people get a little stumped. And I left this 8 times 5 because had this been 40, I wouldn't see the 2 8s, and they're gone. And then also our n plus 1. N plus 1 is gone. So 5 is left on top and n minus 7 is left on bottom. So the answer is 5 over n minus 7. Again, back to restricted values. That would happen before you cross anything out. So n minus 7 equals 0. N plus 1 equals 0. If you want to just out of habit, write 8 equals 0. Just so you don't leave it out. In the event it had been an 8x. Like if it was 8x or like 2p, that is an answer. 8 is never going to equal 0. There's no way I can turn 8 into 0. I've had students say, if you multiply it by 0, it becomes a 0. But that means that x would have to have been there. Or in this case, an n would have had to have been there. And so our list of excluded values is going to be a negative 1, positive 7. So factor, restricted values, then have a tantrum and cross things out. And then in the case of multiplication, just run across and clean up. And that's it. I am pushing right at